Welcome to another edition of VirtualX MasterClass with Mr. Kanyile. Today I want us to look at the Euclidean geometry. This is the geometry that was discovered by a guy called Euclid, hence Euclidean geometry. We want us to go straight to past papers and see how do we solve these problems. But there's one thing that I want to show you. How do you master this session called the Euclidean geometry? There are only 13 theorems that you need to master because all the questions revolves around these theorems. But another important factor is, of course, your grade 8, grade 9. It comes out in your matric examination. Hence, my session for today will start back there. We'll look at how grade 8, grade 9 assist us in our grade 12 matric exams, move to grade 10 to 11, where we'll be talking about circle geometry, as well as grade 12, the 3 theorems that we need to understand at grade 12. This guy Euclid said this geometry originated from just a point. This is a point. This is where Euclidean geometry originated from. All the geometry that you study, it comes from just a point. This guy Euclid noticed something when you put a group of points together. When you put a group of points together like this one, he ended up having something like a line segment. There's so much Euclid that we can learn from just a line segment. We've got 3 types of line. The first one is called the line segment. This one is called a ray. This one is called a straight line. Remember, all this originated just from a point. And if you put 2 lines together at a common point, this is a line, this is another line. And this point here is called a vertex. Something is formed. What is formed there? An angle. This is called an angle. And we've got different types of angles. In fact, we've got 6 types of angles, we've got 6 types of triangles, and we've got 6 types of quadrilaterals, the 4-sided figures. We'll all be going over that section. It is important that we must understand our angles because it will make our Euclid much more easier, and it can even assist us in analytical geometry as well as trigonometry. If you go to your Cartesian plane, it can cover all the angles that we have. Let's look at it. If you've got your Cartesian plane, remember, this would be 0 degrees, this will be 90 degrees, this will be 180 degrees, this will be 270 degrees, and back to 360. Now, all the angles are catered in this Cartesian plane. The angles that are found in the first quadrant, this is the first quadrant, second, third, and fourth. The angles found in the first quadrant, in other words, angles that are above 0 degrees but less than 90 degrees, an angle here, we'll call them acute-angled. We said we've got 6, so the first one is acute angle. An acute angle is above 0 degrees but less than 90. What about the angle which is exactly equals to 90 degrees? Perpendicular. This is 90 degrees. This is called a right angle. That's the second type of an angle. The first one is acute, the second one is right angle. The third one is in the second quadrant. From there to here, it's above 90 degrees but less than 180 degrees. It's called obtuse-angled. So all angles that are found in the second quadrant are called obtuse-angled. After that, we go to a straight line. From here to here, we form a straight line. So this angle is exactly equal to 180 degrees, and we refer to it as a straight line. From there, from here, we go beyond the straight line. An angle that is here is called reflex. Even if it's here, it's also called reflex. So a reflex occupies 2 quadrants. Both the third and the fourth quadrant is the reflex angle. And the last one is called revolution. Angle which is exactly equals to 360 degrees is called revolutions. So these are the 6 types of angles. In your grade 8, that's what you learn, and it will come up in your grade 12. For example, when you talk about angles, if I've got an angle like this, I've got x here, I've got 2x here. In your grade 8, you'll find a question like this and say, solve for x. The question is not actually asking you to find x. It is checking you whether you understand the types of angles. What do we call an angle from this side to this side? It is called a straight line, and it is exactly equal to 180 degrees. From here to here, it's 180 degrees. So I know that all angles that are in this one, they add up to 180 degrees. So solving for x, they was just checking you whether you understand the types of angles rather than solving for x. We know that this angle plus that angle is 180. That's what you must know. X plus 2x will give us 180 degrees. Reason, we've got a straight line. Reason is the very important factor in your Euclidean geometry, because for every statement there must be a reason. So how many x's? This is 1x, these are 2. Together they are 3. So 3x is equals to 180 degrees. Then if I'm looking for x, I divide by 3 on both sides. Divide by 3 this side as well. Divide there once. So x is equals to 3 into 1 does not go. 3 into 18, 3, 6, 9, 12, 15, 18 goes 6 times. 3 into 0 does not go. So x will be 60 degrees. So this is 60. This is 2 times 60, which is 180. So 60 plus 180, I mean, 120. 60 plus 120 will give us the total of 180 degrees. That's how you go about solving this. And you'll see this in a complicated diagram in your Euclidean geometry. Maybe you'll have a figure like this one. You'll have something like this one. You've got this. You should not lose if I've got 60 here. Degrees, I must be able to find y. Even in a complicated diagram, I must be able to pick this one up and see that if I'm adding this plus that, it is 180 degrees. Then my y will be 120. I should not lose the sight of this even in a complicated diagram, because this is how we ask you these questions. That was the types of angles that I wanted to talk about. From there, let's quickly go to triangles quickly, because we're rushing into grade 11 Euclid. So these were angles. If I've got this one, I can see an angle. If I close here, how many angles do I see? I've got another angle there, I've got another angle here. How many angles do we have? We've got 3 angles. Do you know that those tricycles that have got 3 wheels? We call them tricycles because tri means 3. So this is 1, 2, 3, 3 angles. So it's tri for 3 and angle. So that's how this was named. It's triangle. It means there are 3 angles in that figure. Just like in the angles, we start in types of angles, we've got 6 types of angles. So as well as in triangles, we've got 6 types of triangles. It is one of the richest part of our Euclid. It goes from grade 8 up to grade 12. It becomes a theorem in grade 12, things that deals with triangles. What's important there is the first theorem that you learn in triangles, that the sum of interior angles of a triangle are supplementary. This angle plus this angle plus this angle is equal to 360 degrees. Even if you see it in a complicated diagram, don't lose that. If you add those 3 angles, it will give us 180 degrees. If we add them, they give us a supplementary. Supplementary angles means add up to 180 degrees. Complementary means add up to 90 degrees. I said we've got 6 types of triangles. Let's quickly look at them. Number 1, we've got let's look at this one. If this side is the same as this side, the same as this side. Equal sides, equilateral. Lateral means sides, so equal sides. This triangle is called equilateral triangle. This is equilateral triangle, simply equal sides. Now, if the sides are equal, then the angles will also be equal. This is 60, this is 60 degrees, this is 60 degrees. These properties are very important. Angles have got 2 properties. Triangles have got 2 properties. One has to do with angles and one has to do with sides. These sides are the same, equilateral sides. Therefore, all the angles will also be equal. Number 2, I've got to talk about the scalene triangle. I'll try and move as quickly as I can. I'm not going to put it in a standard position. This angle has got that side opposite it. This side has got that angle opposite it. So if the angles opposite equal sides will also be equal. If these sides are equal, those angles will be equal. If these sides are equal, those angles will be equal. If these sides are equal, those angles will be equal. You can use your fingers to make life easier. So angles opposite equal sides are equal. That's another theorem that you apply in your grade 12 maths. So we know that this is called an isosceles triangle. So that's the second one. The third one is called scalene triangle. Scalene triangle. What do I know about a scalene triangle? In a scalene triangle, this side is not equals to this one, it's also not equals to that one. So in this particular type of a triangle called the scalene, there are no equal sides, hence no equal angles. No angle is equal to, and nothing is equal in that one. So those are the first three. So what about the next three? The next three types of triangles are named according to one of their angles. Now, triangle number 4, look at this angle. What type of an angle is that one? Remember, from the types of angles, the angle that is exactly equals to 90 degrees, it is called a right angle. But if we close it, we have a right-angled triangle. This triangle is named according to one of their angles. In this particular case, a right angle. So this is a right-angled triangle. This is a very important type of triangle, because this is the triangle that gives us the theorem of Pythagoras. Remember, you will use it a lot in your Euclid as well as in your analytical geometry. What is it saying? This side is called the hypotenuse. The longest side is called this side is called the hypotenuse. It is the side opposite 90 degrees. It's called the hypotenuse. Out of the three sides that forms this triangle, this will be the longest side. Now the theorem says, in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. It means that this side squared plus this side squared will be equal to that side squared. That's the theorem of Pythagoras. Pythagoras is the name of a person who discovered this theorem. He said, in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Others will even say x squared, which is this side, x squared plus this side, which is y-axis, y squared is equals to r squared. This will be your theorem of Pythagoras. That's what it literally means. But you must understand it that the square on the hypotenuse is equal to the sum of the two other sides. Right, that's a right angle triangle. This is the triangle that also pushes you to trigonometry, because trigonometry is divided into three parts. There's the first part that deals with a right angle triangle. There's another part which deals with angles with triangles which is not a right angle triangle, and the last part will deal with 2D, 3D. Now here it's a right angle triangle. It takes you to the first part of trigonometry, where you talk of your definition. So sine, so katoa. Sine is opposite of hypotenuse. That's where the hypotenuse comes in. When you define those theorems, they are coming from a right angle triangle. So katoa, right? That's the right angle triangle. Number 5. Remember, I said these three are named according to one of their angles. What type of an angle is this one? What type of an angle is this one? It's an acute angle. If I close this, I will therefore have acute-angled triangle. One of its angles must be an acute angle. Then we'll have an acute angle triangle. Number 6, let's look at this triangle. Remember, this is 0, this is 90, this is above 90 now, but less than 180. So it's in the second quadrant. So this angle is obtuse. So if I close it, I will have an obtuse-angled triangle. Right, these are the 6 types of triangles. There are so many theorems that we need to understand when we talk of triangles. I said the first one was that if I've got a triangle like this one, if this is A, B, C, so I know that angle A plus angle B plus angle C will always be equal to 180 degrees. This is very important. This is another very important theorem that we must know. It will assist us a lot. Number two, another theorem that has to do with triangles. Look here. If I have a triangle like this one, and I've got an exterior angle, this comes up a number of times in your exams. Even at the end of this year, you will have a theorem that will require you to understand this theorem. This one says this angle is called the exterior angle. This is the triangle. The inside here we've got interior angles. This one is the exterior angle. We must not lose the sight of what we are learning here, that from here to here is 180. If I've got this one, I will know this one. Because if I add these two, I will get what? 180 degrees. But this theorem that I want to talk about here, it's called the exterior angle of a triangle. It says the exterior angle of a triangle is equal to the sum of the two opposite interior angles. In other words, the theorem says this angle will always be equal to this angle plus this angle. So if I add these two angles, I will get this one exactly as it is. So you might be given this angle and this angle, you are required to find this one. You should not be confused. You must know that this one is equal to that plus this one, and you'll have only one unknown. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That becomes important. I repeat, the exterior angle, this one outside, is equal to this one plus this one. I should not be confused. No matter where the exterior angle is, let's extend it this side. Can you see where is the exterior angle? This becomes the exterior. Therefore, this angle will be equal to this plus this. The exterior angle is equal to the sum of the two opposite interior angles. So that one, even if I extend it from this side, so this one will be equal to this plus that. So that's called the exterior angle. Now, there are so many other theorems that has to do with triangles. I've just spoken about the exterior angle. Let's talk about the concept of congruency. It comes in triangles as well. We're still on triangles. There's another concept called congruency. What do you mean by congruent? If I've got this triangle and another triangle exactly the same as it, congruency, it's like the identical twins. If you've got the identical twins, they are born on the same day, they are born by the same parents, everything about them is the same, and they look the same, they walk the same. That's what we mean by congruency. I'm just addressing the concept congruency. Congruent means equal in all respect. Now, we're saying these two triangles are equal in all respect. In other words, if I take this triangle and put it on top of this one, it will be like there is only one triangle because they are the same. What does it mean? It means that this angle is equal to that one. This side is the same as this side. This one will be the same as this side, and this side will be the same as this side. Hence, this angle will exactly be the same as this one, when this one will be exactly the same as that one. So if I take this and put it in here, it will be as if it's one triangle. So that's what congruency means, equal in all respect. Now, when you cut someone in between, the piece this side will be exactly the same as the piece on the other side. If there is a shoulder here, there must be a shoulder on the corresponding position. Remember corresponding position. If there's a shoulder here, there must be a shoulder on the corresponding position for it to be congruent. If in one case there's a shoulder here and the other shoulder is here, it's no longer congruent because it should be at the corresponding position. Like if this angle must be equal to this one, you can't have this angle equal to this one. It should occupy the same position, corresponding position. So that becomes important when it comes to congruency. There are 4 cases of congruency. You don't have to check everything before you conclude that the two triangles or the two things are congruent. In this case, when we talk of congruency, we refer to them to triangles, even though there are so many other objects that are congruent, but in mathematics, because we want to make life easier, when we talk of congruency, we refer to triangles. There are 4 cases of congruency. I'll quickly go over them. 1, it's side, side, side. What do you mean by side, side, side? We mean if I've got 2 triangles, I've got to show that this side is the same as this side. That's the first side. So side compares to 2 sides of 2 triangles. So when we say side, we are saying this side is equal to this side. When we say side again, we're saying this side is equal to that side. That's S, this side is equal to that side. If that is the case, if we've got two triangles with three pairs of corresponding sides, this side corresponds with this one, it takes the same position. This one corresponds with that one, and this one corresponds, we call them corresponding sides. Remember, we talk of corresponding and there are no parallel lines. Don't only confuse corresponding with parallel lines only. It has to do with position rather than parallel lines. Now, when we say side, 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 we are comparing these sides that they are the same. If the sides are the same, if one side is equal to this one, and this one is equal to this one, and this one equal to this one, therefore the corresponding angles will also be equal. You don't have to prove the corresponding angles. Automatically they will be the same. That's the first one. Number two, it's side angle side. What do you mean by side angle side? Let me just make an example. If this side is the same as this side, that's side. If this angle is the same as this angle, that's angle. And this side, the same as this side. I can't take that other side because the angle is here. Because the angle that we must, that is involved is called the included side, the included angle. What do you mean by the included angle? We mean the angle that is between the two sides that we are talking about. Remember, we're talking about this side and this side. I can't go take another angle. I've got to take the angle that is in between the sides that I'm talking about. That's what we mean by included angle. The angle that is between the two of these sides. All right, that's side angle side. The third one will be angle angle side. The fourth one will be 90 degrees hypotenuse and the side. Of course, this one will work in a right angle triangle because there's 90 degrees and there's hypotenuse. So if we're comparing two triangles that are congruent and it's a right angle triangle, we go to this case of congruency. The fourth one, which is 90 degrees hypotenuse and side. That's another important feature in your Euclidean geometry. If we understand congruence, it will be easier for us even to prove theorems when we go to grade 11 and 12 stuff. Another concept after congruence that I want us to understand is the concept of similar. This is still grade 9. Similarity. This also comes out in grade 12, and yet it's the concept that we have learned in grade 9. Similar does not mean equal, but they look the same. For example, you and your mother, you look the same, but you are not equal. You are not of the same age. Maybe you walk the same way, maybe you talk the same way, maybe so we say you are similar. You are not congruent. Congruent, it's like identical twins, equal in all respect. Similar, one is big, one is small, but they look the same. They even talk the same, they walk the same. That's the concept of similarity. And it is there at the end of this year where they say that prove that these two triangles are similar. Right, similarity. Let's make an example. We've got, this is your mother or your dad, and this is you. You look exactly the same. The only difference is that your dad is big or your mother is bigger than you while you are still young. If this is A, B, C, this will be D, E, F. You've got those two triangles which are similar. Similar simply means there are features that are the same between you and your parent. In this particular case, the angles, because we're talking about triangles here, those features will be angles. Those angles must be the same, the corresponding angles. The eyes, your eyes and the eyes of your parents, they are in the same position. You can't have eyes here and eyes here. The eyes must be in the same position for it to be similar. So in this particular case, if this one is equal to that one, this one, this angle here, angle B, is equal to angle C, angle E, and angle C equals to angle F. Then we can say the two triangles are similar because they've got the same features. The corresponding angles are the same, equiangular. That's the concept that we use when we say two triangles are similar. We say they are equiangular. It means that their corresponding angles are the same. This one corresponds to that one, it's the same thing. This one corresponds to this one. If you've got such a situation, we say the two triangles are similar. We compare the three corresponding angles that they are the same. And when you prove it, You don't have to prove all three. Because when I add this plus this plus this, what do we get? 180. When I add that plus this, what do I get? 180. So if I can show that this is equal to that, that's one angle. Number two, if this is equal to that, that's second angle. Obvious, this one will be equal to this one, because it would have been the third pair. Because both of them, when we add them, they give us 180. So if this one is equal to that, and this one is equal to that, you can conclude by saying that angle C will be equal to angle F, because it would have been the third pair, because both of them, they add up to 180 degrees. So when you prove that the two triangles are similar, focus on two angles. Check the two angles that you can equate between the two triangles, then you can conclude on the third one and say it is the third pair. So that becomes crucial when proving this. Now, similarity only does not deal with angles, and there's got some special features that has to do with sides. This theorem says, if two triangles are similar, what we mean by similar, we mean corresponding angles are the same, where A equal to D, B equals to E, and C equal to F. That's what we mean by similar. Now, if we have that situation, then the ratio of their corresponding sides will be the same. What do you mean by that? If I've got two triangles that are similar, it simply means that this side, which is AB, over ratio of something over the corresponding side there. This is AB, it corresponds with which side? This side, with DE over DE will be the same as AC corresponds with which side? That side, DF. We can even add the third side, BC over EF. This will, if this is the case, therefore the two triangles are also similar. If the ratio of the corresponding sides are the same, then the two triangles are similar. The theorem says it's a metric theorem that you need to prove. The proof of the theorem is required in grade 12. It says if two triangles are similar, then the ratio of their corresponding sides will be the same. Ratio is the same of the corresponding side. This one corresponds with that one, so this over this is the same as this over that, or the same as this over this. In a practical situation, you might let's do it like this. Let me take this one off and compare these two. In a practical situation, you'll be given 3 dimensions and you're required to find the fourth one. You'll be given 3 and you're required to find the fourth one. Let's make an example. If these two triangles are similar, and we are told that we don't know the value of this side, let's call it x. Let's call this one 5 units. Let's call this one 8 units. This one corresponds with that one. Let's call this one 4 units. Okay. What do you do when you've got a scenario like this one and you are told that these two triangles are similar? Or at times you need to prove that these two triangles are similar by showing that this is equal to that and this is equal to that, then conclude that this one is equal to that. Then you can say the two triangles are similar. How do you go about solving for x if the two triangles are similar? Remember that if two triangles are similar, then the ratio of their corresponding sides are the same. In other words, this ratio must be the same as this ratio, must be the same as this ratio. Let's write down. Let's solve for x. How do we go about solving for x in a problem like this one? We know that since the two triangles are similar, then x, which is AB is x over BE, over DE, I mean. What do we see in DE? We see 5 is equals to AC. What do we see in AC? We see 8 over DF. What do we see in DF? We see 4. Then you solve for x. You cross multiply. So x will be equals to 8 over 4 times cross multiply times 5. What is 8 over 4? 4 into 8 goes 2 times. What is 2 times 5? It is 10. So x is 10 units. If you are not given the dimension, this is 10 units. You can see that one is half of the other one. If this is 8, what is the corresponding side? It is 4. So if this one is 5, what will be that side there? It will be 10. Hence we got 10 there. This is how you go about solving this theorem. Remember that we are just talking about triangles. We started from a point, we develop into lines. So these are the triangles. What else is important? I think when we're talking about lines, I think there's another very important part which we left out, which I want us to go back to. If we've got these lines, let's look at these lines. Let me call this 1, 2, 3, 4, 5, 6, 7, 8. Right. Do we have corresponding angles there? What does corresponding has to do? It has to do with the position. This one is on top of the line and number 5 is on top of the line. So those are corresponding angles. Some people would think that things will only correspond when they are parallel lines. There are no parallel lines here. Yet we say angle A corresponds with angle D. So corresponding has nothing to do with parallel lines. But let's involve parallel lines and see what I'm trying to show you here. Once we have this line and this line, and I'm saying these two lines are parallel and they're cut by a transversal line. If I've got 1, 2, 3, 4, 5, 6, 7, 8. In this case, this side in the first diagram, angle 1 corresponds with angle 5. Angle 1 corresponds with angle 5. We call those corresponding angles. When we talk of corresponding angles, like angle 1 corresponds with angle 5. This side, also angle 1 corresponds with angle 5. What is the difference between these two corresponding sides? These two corresponding sides are not equal, because the lines are not parallel. Where the lines are parallel, then the corresponding angles are equal. So when you see parallel lines, you think of this. When we talk about corresponding angles, in this particular case, the corresponding angles will be equal. In this particular case, corresponding angles are not equal. Angle 1 is equal to angle 5, reason corresponding angles. Angle 2 is equal to angle 6, reason corresponding angles. So it has to do with position. You see this position. It is the same position as this one. And you can see this is an acute angle, small, that's an obtuse, the same. Acute, the same. So this one corresponds with this one, they are equal. 4 is equals to 8, 2 is equal to 6, 3 is equal to 7. Those are called corresponding angles. They occupy the same position. We also have alternate angles here. 3 is alternate to angle 6. They are equal if the lines are parallel. 3 alternate to 6, but they are not equal because these lines are not parallel. So 3 is equal to 6 alternate angles. 4 equals to 5 alternate angles. These are called interior alternate angles. They are inside the parallel lines. We also have those that are outside. This one is alternate to 7. Angle 2 and 7 are exterior alternate angles. Angle 1 and angle 8 are also alternate angles. This will assist you even in a complicated diagram. We'll look at this where there are parallel lines. In your example, you only talk about twice with parallel lines. It's when you talk about this scenario where we will look for alternate angles, corresponding angles, or when you look for the theorem called the proportionality theorem. When say a line drawn parallel to one side of a triangle divides the other two sides proportionally. We'll do that one later. Also here, which is important, are called co-interior angles. Co-interior angles, they must be on this line is called the transversal line. These two lines are co-interior angles. They are on the same side of the transversal line. In the same way, 4 and 6 are co-interior angles. All the time when you add the co-interior angles, you'll get 180. In other words, angle 3 plus angle 5 is equal to 180. So if I've got this one, angle 3, as equals to 60 degrees, I will know that angle 5 will be 120, because 60 plus 120 will give me 180. So if I've got one, I must be able to find the other one. So this one plus this one are co-interior angles. Interior means inside parallel lines. We also have co-exterior. Angle 1 and angle 7, they add up to 180. They are co-exterior angles. So is angle 2 and angle 8, they are also co-exterior angles. This becomes important. It always comes out in your examinations. In fact, in all the papers, you will see this either in analytical geometry or in Euclidean geometry. So it comes in handy. Then the next part will be your quadrilaterals. Your quadrilaterals will help you more when you are dealing with of course, your analytical geometry, because your analytical geometry will deal with figures. The four-sided figures, they are also 6. It is important that we must also master them. From here, I want us to go straight to grade 11 Euclidean geometry. I want us to look at one theorem that is done in grade 10, which is called the midpoint theorem. If we've got a triangle like this one, what is the midpoint theorem saying? If I've got a line halfway, if this is halfway, in other words, if this distance is the same as this distance, and I've got a line that is drawn parallel to this line, And also this part is the midpoint. So this is the midpoint, that's a midpoint. The theorem says, if this is the midpoint, this distance from here to here will be half of this distance. In other words, if this is drawn in the midpoint, and this one is 2 centimeters, the theorem says this definitely will be 4 centimeters. This is what the midpoint theorem says. If you don't understand this theorem, it will make your working a bit difficult. So it is important that you learn this theorem from grade 10. It's called the midpoint theorem. If this is drawn from the midpoints, this distance of this line will be half of this distance. So that's a very important theorem from your grade 10. Now let's move over to grade 11 geometry, which is called the circle geometry.